協力をお願いいたします。
Any other question or comments? Thank you for your presentation.
次だ。あ、じゃあちょっと今僕関連のペーパーをちょっと持ってるからちょっと待ってね。
山岸君ちょっと節さんを先に。
はい。
節さんをボロボロの事情で先に。
あ、はい。じゃあ準備。
これいや準備始めてください。OR 学科に書いてあるやつでね、ちょっと10部しか今コピー取ってないんで、これは今日の節さんのやつと関係するから。あと残りの人のやつはあと誰かコピー取ってついでにコピー取ってください。これ本当はフルでもっと倍以上の分量書いたんだけど OR 学会の解説なんでこれしか書けなくて大幅にカットしたやつですけど、エージェントベースモデリングとシステムダイナミクスというのはマクロアプローチとの差について書いてあるやつなんで、ちょっとまだ構成前なんですけど、途中で切れたら残りは適当にコピーして。これあと1、2、2部かな。僕は5時半ぐらいにちょっと抜けます。ちょっとまたお金の打ち合わせがあるんですいません。そうそう。
さすがにそんなに早くはない。
いや、梅ちゃんは早かったよ。5時半ぐらいからいたからね。始発で来てたからね。いいじゃない、はい。始発で来て終電で帰る学生の後にも先に梅ちゃんだけですよ。
これ決めって
できれば名前は書いていただければ嬉しいです。
Okay, now let's start.
My topic is system dynamic method on infectious model. Because this is initial, so I welcome a lot of comment and suggestion about this one. Okay, let's start. In the past 2 weeks, I found some background about by modeling and simulation to use StackMySearch to solve the problem of the epidemic transmissions. There are 2 ways to solve the problem of epidemic transmissions, that is, infectious. One is object-oriented method and agent-based models. Method. I compared 2 of them and list the 3 of them. The first, for the object-oriented method, the objects have a passive action. But on the contrary, for the agent-based method, agents act on their own initiative. This is the special for the agent-based method. For the object-oriented method, they put emphasis on date instead of the effects comes from the circumstance. Well, the agent-based method agent change their collection depending on the time and the situation. For the third one, there are some famous models about the object-oriented method and agent-based method. APSIMS, an academical simulation system. They mainly talk about the firewall, and for the agent. Oh, sorry, maybe I misunderstood. Here, two of them put emphasis on the agent-based model method to solve the problem of infections.
Okay, in this stage, I'll give some comment. Well, you mentioned about, or you compared the two approaches, object-oriented approach and agent-based approach. This is a comparison about, so information technological point of view. So not so epidemic issue. Actually, epidemic modeling, there's no object-oriented method. It's a kind of implementation way of modeling. Okay, so of course, macro modeling and micro agent-based modeling is a modeling way of so epidemic issue. Okay, but object-oriented is a programming concept. The conceptual layers are different. So methodologically, that kind of comparison have a bit problem. Okay.
Yes.
Okay. Anyway, please.
I misunderstood this topic that.
Yeah. Comparison is
About
about
different-
so programming issue, so not modeling issue. Okay. Anyway, please continue.
So to check whether this model is appropriate enough, we have some tools to check it. The first, we must for a good model, they must reflect the people's actions in the main, and people have ability to infect and transmit virus. The system can reflect the precise and speed of transmission, and for the good model, the model must forecast the development of tendency and reflect the influence after taking different measures to control the infections. This all of them, such as the tools to say whether this model is good or is bad. This one I have presented in my last presentation about actually this comes from the system dynamics. For the system dynamics, the society can be divided into the 6 floors. I use the concept to solve the problem of infections. And I list the 6 of them for the people floor and the order floor, information floor, equipment floor, and materials floor, money floor. I aim to combine 6 of them in one system. For the model, I must reduce the conditions because this is too huge. So I set some conditions for the air. I just put emphasis on the city because of the density of populations, the city get more harms about the infections. For the transmit pattern, we know for the infections, they have a lot of patterns transmit, such as the Morse-Lee and water transmit, such as insect infections. But I only put emphasis on the contagious infections, and this is non-conscious actions. It's just useful on our usual lives. The main action that can take some time in daily life. For the preliminary design, it's just like the outline about the model. For the application, there is no doubt that the application is to obtain the infection control. And for the simulation part, I divided it into this fourth one: interactive relationship, humans movement, supply of materials, and equipment arrangement. This reflects the flaws I have presented before. For the model is that the human circumstance in epidemic area and utilizable materials. Just follow them, like I put some agent and put some factors into the system. The date I want to know is population distribution, some information about the areas, and some reference of materials. This is the paper flow. I think many people have done a lot of work to solve the problem of the paper flow. It's just like the SIR model. This part susceptible, removed, and infected. The SIR model. And I divided it into the three parts: the latent period, early period, and clear period. They take the different times for the different infections. I set the example that the smallpox, the latent period maybe the 10 days, and another one maybe at a different date.
Sorry, that's called exposed period or clear period? I have
Clear period maybe in the later, the people may feel they really have sick. They really have sick. They must go to see the doctor. But in the latent period and early period, they don't know. Or they want to think they have had the disease. They don't want to take to see the doctor. So the disease will be delayed. This depends on the different people.
Anyway, you assume the patient all inside the hospital.
Yeah.
Okay. But in many cases, not hospitalized. Okay. Okay. So under the isolation case, maybe, but it depends on anyway. So have you looked our smallpox model, or so agent-based modeling developed in this laboratory?
Sorry.
Actually,
Just know some background of it.
we have developed
Clearly about it.
so several types of agent-based modeling, especially smallpox models. So it's one of the famous ones that was evaluated by MI5 specialist of terrorist attack agency. So anyway, so our approach is a typical agent-based modeling approach. But in your presentation, you are talking about system dynamics. But system dynamics, but your approach of system dynamics is rather, rather mixed version. But anyway, system dynamics come from stock flow approach, So, for example, so you should understand the methodological meaning of agent-based modeling and also system dynamics. System dynamics have a special limitation. So many people move to agent-based modeling. So it's quite different, especially so for example, SIR. Okay, this is maybe sometimes population or population ratio. Okay, so for example, in simple case, or level 0 and the infected case. So sometimes infected case might be divided into several stages. Okay, anyway, and also removed. That means that dead or maybe recovered. Okay, anyway, so that kind of cases all anyway, so this is a population, and well, this means about maybe population ratio or population into self, this type of this. Then, well, but in each agent, these type of state transition will happen. So that means the well, total number of people. That means the well, okay, this is a small s. Then use large s, large I, and large I, large R, okay? And small s and small I and small r instead of this one, okay? And this means well, so state of each agent. Then, for example, S means well, total number of people. So that means well, agent. And, okay? This is the agent, okay? So, and maybe, so state of agents, small s or I or R, okay? This means the well, state of omega, okay? You understand? Okay. So that means the large S means the well, you understand? So that means the well, total number of agents, and that state is a small s. Okay, okay. So, like ourロトカボルテのモデル, that kind of ecological model have the same structure. That means well, total macro variable can be constructed from total number of some state of agent. Okay, so agent transition model. If agent transition model can be described this kind of a kind of Markov chain or chain model, then macro variable model can be aggregated to that kind of mechanism. Okay. But well, in systems dynamics, so delta S st plus 1 equal st plus delta S. In system dynamics, okay, S. Anyway, so S is not increase. So, for example, in the case of I, so increasing plus I flow and minus I flow, delta I flow and delta I flow calculated, then total stock of I change. So this is a typical type of differential equation that describes system dynamics. So system dynamics describe the macro type of stock and flow dynamics, multi-dimensional. So that not describe this type of agent-based transition pattern. So agent-based model describes that kind of detailed transition pattern in each agent. And after that, aggregate that kind of macro value. So of course in agent-based on some type of system dynamics, they divided state so many different macro parameters and then describe that interaction. But it's quite different to agent-based state transition pattern of description. So we say this kind of macro description is an unfolding of macro variables. And this type of aggregation is called folding of that kind of micro parameters to macro variables. So that kind of, about that kind of methodology we described in this Japanese paper. So that kind of methodology is very, very important. Just our laboratory is developed that kind of methodology. And especially we introduce some activity in the city, then it is very difficult to introduce directly that kind of agent activity into this type of macro stock and flow variable. Because that described, this type of transition mechanism was more unfolded than the activity model of each agent, and some type of virus protection policy of each agent, and then so on. That kind of model are combined, and so this is the simple one, but unfolded to the combination of different models. So CT activity model and virus protection models, and then so on combined in agent-based approach. Then so folded into the macro variable. But in the macro variable layer, it is almost impossible to describe that kind of so each activity in stock flow dynamics language itself. Of course, some similar but simple one can be introduced directly from that one. But it is a stock flow dynamics is a characteristics of system dynamics. So you should understand the difference.
I see this belongs to the different areas because I will combine the sixth part. I think maybe one part I can deal with the date in one part use the system dynamics because I don't know how to do this part into the.
So system dynamics or stock flow data can be calculated from so some folding or aggregated process of microdynamics. Okay, so the system dynamics, system dynamics approach is directly describe that kind of stock flow interaction with it between so many variables like our I. For example, in this case, it's I and okay, S determines delta I. Okay, so, and I determined S and I determined delta I, and I determined delta R. Okay. Then I alpha I, that kind of equation should be described. Because this macro variable and this macro variable affect to this delta I. Okay. That kind of macro relationship is described, so this differential equation was determined by this type of macro interaction. And in system dynamics, this was written by some diagram. Okay? But it's a typical type of differential equation construction way. But micro approach, this should be calculated as an aggregation process. Okay? This is the difference from so system dynamics direct formulation. System dynamics or SD programming method always starting from these type of macro variable interaction. So sometimes that introduced some parameter like a micro parameter, but micro parameter interaction is not described at all. Obviously, in addition, sometimes so combined model can be introduced, but this is the additional hypothesis. So maybe what? Definitely microdynamics. What kind of microdynamics should be unfolded? In simple cases, so state transition dynamics might be enough, but sometimes city transportation or city moving dynamics will be required, and another dynamics will be required. Then depending on the purpose, we combine small agent-based model that can define very, very complicated but realistic boundary condition for these type. So that kind of boundary condition cannot be described directly by these type of differential equation. That is the point. Macro differential equations cannot describe complicated boundary condition directly. So we unfold that kind of macro variable to micro variable, like our thermodynamics to statistical dynamics. So that kind of unfolding process is a core concept of agent-based model. In these days, so many people love that kind of macro approach. Okay. So and traditionally, because traditionally physical scientists and physical mathematics coming from that kind of direct formation of equation. So actually, well, 1 week ago I talked about system dynamics analysis at Aalto University. His combined approach is well, system dynamics can be described that kind of way, but some parameter can be determined by microdynamics calculation. That is a way of some combination. But actually, if we focusing on so many realistic boundary conditions, that boundary condition means sometimes traffic structure or population structure, or for example, what kind of age bracket and family structure, okay, and what kind of vaccination policy or that kind of policy. That means a boundary condition of the model. Okay, you understand the meaning of boundary condition. So that kind of boundary condition can be described on micro level, okay, but not macro level. So we need some unfolding. That kind of methodology of agent-based model is just where constructing. Okay. So please look the difference. Actually, in these days, so many different approach of agent-based model exist, and sometimes system dynamics model and with some micro approach combination is called agent-based model. But we are now developing a pure type of agent-based model, and the interaction itself we are interested in, because in some cases, micro policy maker not refer directly the agent, but aggregated parameter they differ and introduce some policy. That is the typical type of micro-macro interaction. So in that case, aggregated variable play an important role. Actually, in economical systems, real politicians refer to macro data. Okay. In that case, natural macro and micro interaction happen. So anyway, in epidemic or public health domain, so many type of micro approach should be developed. Okay. So of course, maybe every epidemic model start from this type of SIR or that kind of micro approach. That is directly connected to system dynamics or structural dynamics. But more unfolded dynamics, we should pay attention. Okay.
I think they belongs to the different areas. One is belongs to the micro and another is the macros.
Yeah. But the point is that not formulate the relations. So from a macro point of view, macro variable is very, very important. But the macro formulation is not so important. Okay. That's the point. Okay. That's the point I'd like to say about the system dynamics. Anyway, please continue. But anyway, for all person, it's a very, very important point for agent-based modeling or micro approach. What's the difference between micro approach and macro approach? That is methodologically very, very important. And also, it's actually emerging methodological domain that is now under the discussion. So in this April, I attended only one Japanese, as only one Japanese to the conference of epidemiology of modeling and simulation and modeling, EMS. That conference focused on the methodology of simulation for that kind of very, very complex simulation. So in the conference, I explained that kind of folding and unfolding approach. Actually, folding and unfolding concept include more and more different type of concept, like our tabletop exercise. In that case, is model itself. So our decision maker is included also the model itself. That kind of modeling methodology is also very, very important for social problem solving. So it is traditionally called action research or that kind of approach. So this is a typical type of systems analysis. Anyways, so that kind of agent-oriented approach, not only agent-based, is very, very important in these days. So please, please focus on that kind of methodology also in your approach. Okay. ということで続けてください。
すみません。
はい。
I think maybe there are some problems about the team in this presentation. I use the system dynamics not in this part, but in the materials flow in the next part. Should I continue to complete this part? I set some characteristics about the agent for the every agent is actually the people in the system. For the every people in the system, they have the different characteristics. I divided all of the characteristics into several parts. The identity, body type, age, neurolocation, vehicle, immunity, infected stage, and precautionary. Depending on the different people in the system, they have the different identity, body type, and age, and a lot of different things. That means they have the different probability to get the disease.
Okay. Actually, please look our developed model that include almost all factors. And もしもし出口です。Maybe now Gwen さん know very well about that model.
So there is no need to continue this part.
お、はい、もしもし。はい、もしもし出口です。あ、はい、つないでもらいます。はい、すいません。あ、もしもし。あ、いえ、こそこそ。はい。はい。はい、話は言ったやつを先生とか転送しましたんで。はい、あれ、先生とこ転送ついてないですか。あ、ごめんなさい。はい、山本先生から原瀬名先生に連絡が行きまして、それで、はい、はい、はい、大丈夫です。
続けていいんですか？いいですよ。
続けてる。あ、ごめんなさい。あ、ちょっとどうぞ続けてください。ちょっとだけ。あ、すみません。29日。
Maybe there is no need to talk about this course. So test all of them.
ちょっと待ってください。
Okay, that is another flaws, materials flaws.
ちょっと
I
待っ
think
てください。
for the completing materials flaws, it should be it should include a lot of factors like the demand, supply, logistic, feedstock, facilities, and a lot of things.
今ちょうど夏ゼミをやってるんですけど、
Especially, I want to put emphasis on the sentiment. The sentiment reflects on the probability that the agent want to accept therapies when they are during the latent period and the early period. Because in the later period, the patient definitely have got things. They must go to see the doctor or they will die. So
はいはい。
this sentiment is no need to use to the later. No need to use to the later period. And for this one, the main structure. This is the interface I want to put the two floors into together. The people flow, the people we can get the demand forecast depending on the people flow. We get the date from it, and so from this one, the sentiment, the people in the system have their own consideration. And they use their considerations to control their sentiment, and the sentiment will affect the real supplies in the system. So this is the outline in the materials law, I think. I want to get some data from this board. Actually,
Sorry, I cannot understand. So, please back one page.
okay.
I cannot catch what's the material for.
All the materials law,
Oh.
they include.
What's the relationship between that model and the epidemic model?
Because in the materials laws, they supply the mask, the drugs to the patient in the paper form.
Ah,
this is the
that means the treatment model. That
yeah.
means, okay. So that is a rather public health problem, not in the hospital, but city or government levels. Okay. That is a very important point for focusing on. Actually, well, epidemic issue is not only inside the hospital, but also city level or big, district level issues. So in some, very wide domain, we have to construct a plan for treatment, not only protecting but also treatment. In that case, it's so not only medical treatment but also medical logistics or that kind of supply process is very, very important. So I think I recommend you to focus more about a public health issue, not only infection. So public health issue includes that kind of logistics or so many aspects for our public health situation. So actually, okay, please.
Actually, in this system, I want to check the effective about the social insurance to take some drugs and to take many measures and affect the delays and affect the tendency of the delays infections.
And so and also social insurance or that kind of payment of patients. That is a very, very important or real public health issue. I recommend you to introduce that kind of factor. Then it becomes a real social simulation or social approach. So actually infection itself is a rather partly natural issue, okay, natural effect. But of course, the human activity process is a social issue. But also, treatment process and national health insurance system is a typical type of social issue for not only infection but also wide range of public health problem. So I recommend you to discuss that kind of one. That is a very, very important issue.
I will put more emphasis on this point. This is a structure, and there are two interfaces to connect with the people. The first, the social insurance must get some plan to supply the drugs or masks or a lot of supplement to the sick. So they get some data from the paper flow that I recommended before. After they set the demand forecast, there are three factors into the system: the feedstock, the facility, and the specifications. And three of them establish the master production schedules.
Okay, but it's except so well, medical or public health domain. That kind of stock and flow is a typical application of system dynamics. You know, so don't apply directly that kind of concept. Please look realistic situation at first. Okay. You know our developed VR game approach. Okay. It looks like a very typical that. But in these states, well, so medical pill logistics is a bit different from the VR game or that kind of stock flow approach. Realistic processes, bit different. So please look at a realistic situation, especially not only Japan but also your country. Okay. Yeah.
Actually, for the logistics, this part, there is a subject to describe this part. And in the last, this is a real supply. Depending on the real supply, the government or the social insurance will plan to another demand forecast in the next. It's just like a recycle, but we cast a lot of the sentiment into this system. That's all.
Okay, 他の人、僕はもうたくさん言ったから。
So what do you want to do in your master course?
Actually, I want to complete this system.
Which system?
I don't know if it is available or not.
You mean that you want to combine six flow?
Maybe it is not available.
Could you show me the picture? In my case, I spent 2 years to make a virtual simulation city.
Actually,
Because
right.
we have a lot of
I know
models
that.
about
So I think you cannot make this kind of combined model in 2 years. Maybe I think it takes more than 5 years. The one flow, maybe 2 years, at least.
because I see we have done a lot of works about this part. So I mean, if I done this,
Yeah,
if
that's
I
a
have
good
chance
point.
to complete this part, maybe
And
maybe it is, but
yeah,
it is in initial.
just to focus on the logistics for is maybe a good point in your master course. And the point is that that the people flow or maybe maybe that if you use that, for example, my research or Min's research or Tanuma-san's research, you can combine this, you can make this kind of model because my main topic is urban simulation. And Tanuma-san make some framework of infection transition model. And Min-kun is now focused on the hospital case. So from this picture, there is no model of that one. But the point is that Yamagichi-san also interested in that point. Logistics. first step maybe you should learn more about this domain. Not only the other research, but also in our lab's previous research. Then maybe you can find a new point or your interest point.
Actually, this domain is just developing area. So except some toy model in so many type of business modeling, we want to construct a real social infrastructure for any government or any people in the world. So for that purpose, we have to construct a reliable and also reproducible modeling. So as well, for example, as well standard library in application library in SWORDS. So I think there are so many things to do. Actually, at first step, you think, oh, this was already done, this was already done, and so, there are so many things to do. Okay, so at first, please, survey, our research, vision, and also our works, and also more realistic situations. Sometimes all students try to apply one paper to another one, okay, or combine one paper approach, two paper approach, and paper work. But the paper is only a paper, okay? So system scientists have to change the world. Paper is only a step to live through in academic situation. Okay.
You can find some posters there.
As I change the team.
And please look at this methodological paper, unfortunately Japanese. And I have a more extended methodological paper. So maybe I'll upload on first class. So that kind of methodological discussion is also very, very important. Why microprocess is different from macro, and why people want to write down macro equation directly, and what kind of approach that was done. Actually, from a micro approach point of view, there are so many types of approach. So what kind of approach we are doing, and what kind of limitation that type of approach have done. So that kind of methodological consideration is essential for system science. Okay? It's time. Advance. Bye.
Thank you very much.
今日はまだ撮ってない。新宿の喫茶店でやるから。すみません、学生さんのことあれば、金の話だけしても。沼さん理事には、天敵だからさ、いつか
月曜日の9時から11時からもしくは9月3日の3時までの
9月3時まで午後3時まで9月6日の朝一番がいいですね。
じゃあ9時とか10時とか。
はい。できたら10時から。
ちょっとじゃあ今ここで電話。
Maybe survey the previous similar research or previous results first. Don't think about your model. Yeah, you should survey the background first.
Actually, you're anyway, so yeah, conceptualization is very, very important. So total, look the total, vision, construct the total vision is very, very important. So, but your vision So actually, well, that is very very important aspect. But also at the same time, you don't know what kind of approach is that in each area and how total vision is difficult to attain. If you cannot so evaluate that kind of so each process difficult way, what kind of model each process is required, then well, that kind of vision is only a vision or simple construction. So that please survey.
I will think of myself. Thank you very much.
Maybe you can spend 6 months, next 6 months for survey that.
それであと僕の担当の資料もお願いします。
今です。
お二人次回はネタさん点滴なんだよな。10時から10時半。いやレールセンターの件で9月以降やるっていうのはさ、もう高木さんがやってるって言うからさ、何の問題も向こうにはないのにさ。ね。
あれ
野村は負けるんじゃないの、東工大学で長野の官僚してるから。怒ってる。
それはそれ、これはこれ。
言うことないよって書いただけで。
言っ
ちゃったから。
でも、しゅんさんが、認証金を受けるための書類に対する最後の
よし。ドクターとしていい仕事をぜひ頑張ってやってください。場所大丈夫なの？石川さんからコメントできたけども、
G さんにしたんでしょう。G さんの方にした。はい。
G さんは使えるの
？G さんは使える。そこは使えない。
そこは使える。初めてじゃん、実際に初めてじゃん。引っ越さないでね、これ責任者本当に責任取れるからね、これシャレになんだからね、火を起こしたらね。分かってるね、君ら。火事を起こしたら本当に責任者として吊り下げられるからね。
サマースクール、サマーワークショップ、ソースワークショップの方は
後で書く職面って自分で書くの、実質社会の常識、実質はここまで。職名とかそういうやつは、あとは要するに、橋村さんに書き方聞いて。
はい。はい。東工大作家
僕、火事の現場に居合わせるの得意なんでさ、今まで自分の責任じゃなかったけど。システム科学の教授の研究室って
組織がされてないみたいな。
いや、必ずさ、2チャンネルでどこだとかさ、ツイッターかなんかにあそこじゃねえか、いつもつぶやいてる。
それで俺もこの間参加したことあるから、あれはまずいと思ったみたいな。
火の神の甘いとこでとかさ、火事だけは注意してね、シャレのきだから。両方が悪いけど、悪いけど。カメラさん、なんか出てきた？あっちから出てきた。
あ、まだですね。ジャスト
やりますか？やりますか？次でもいいと思います。どうします？
あ、そうでもありますか。
ちょっともう4人とか絶対。
おじさんはちょっとみんなのために稼ぐお仕事に行ってきます。
あ、
じゃあ先月やらないですか？
ここに4人いるんですけど、でも次回に4人回すって っていう案が出てるんですけど、
次回って何日？
次回は
まあ
21日なんですけど、
いや
あ
それなら
別に入れてもいい。
1じゃなくてももう一回
はい
先生方がまあ
まあいないんですけどね。
ご都合のいい
来週
出
は
張でいないんで。
出張で、再来週は秋葉で集中講義
だからないんだよ。
だから21
だから今日にまとめてもらったんだよ。
いやでもまあ別に俺がいなくたって
私がいなくたって。
皆さんやってなんか、まあ、さっきのやつも代表に皆さん代表としてのコメントだったりだからね、まあ、大体同じようなコメント来ると思えば間違いないからお互いに議論しなきゃダメなんですよね。まあ雨がダーッと降ったら逃げてもいいから俺も痛いんだけどそういうのがあんのか
じゃあ今日このまま4人残りやるか、他日にちを開けるか、あとは21日のゼミって何をやるんですか。21日まで伸ばすわけにはいかないですか。
別に残して
いいんじゃない。今日このまま4人やるよりいいと思うんだけど。
じゃあその
でもやった後また改良してやってもらうと全然いいんだよ。とにかく1回でも喋った何回でも喋るんだよ。喋った数だから頭に。
それは別にどっちでもいい。
じゃあ、今日このまま4人続けてやるか、自主的にやるか、21日にやるか、3着でお願いします。
自主的って何？
自主的っていうのは、出口先生と市川先生が出席できないけど、学生だけでやるっていうことです。ああ、
その自主的は多分プレゼンター依存だよ。
プレゼンター依存。
別に発表する人が別に俺とか出口先生がいなくていいっていうんだらそれはそれでいいし、残ってる人でどうしてもいる時にやりたいっていうんであればその人優先すべきだと思う。
あ、その4人が決めるべきってことですか。じゃあこのままじゃあ4人残り4人を今日やるかどうかだけ決めたいと。
いやまあどうしたいのかで、ね、用意してきた人たち。
ああ。
別にだから伸ばしたいっていうんだら別にそれはそれでいいって構わない。
じゃあ発表者が決めるっていうことにします。三沢さんと岩井さんと。
いやだからそれもだから完全に多数決にしてくれても構わないし。
まあ続けて聞く方もまああれなんで多数決でいいと思いますけど、じゃあ今日やるかやらないか聞いたわけでいいですか。
言ったでしょ。今日はやめたい人でいいんじゃない？もう。でしょ。疲れた。
じゃあ今日はもうこれ以上続けるのは難しい。
でも先生方いなくなっちゃうなら発表者でこれから発表する人でちょっとこう聞いてここ心配とかこう聞きたいっていうのがあれば全然やってもらった方がいいと思うけど。
来週にしたら丹野さんがしゃべるから別に。まあちょっとポロッと言うんだったら1週間の間にそれだけサブが出てくるんだろうなって今日のため言われてるんだからそれぐらいのサブが出てくるんだろうな。そういうことだよね、伸びるってことは。今日なんか他の人が言われて自分がやばいなっていうのを埋めてくるんだろうなっていうのはある。
よかったね。
そりゃそうでしょ、伸びるって。
まあそれを踏まえて。
先生発表でなプレッシャーかんだ君らだけじゃないからな、ちゃんと毎週毎週プレッシャーかけながらやってるから。
特に命令する気はないので、学生さんで決めてください、どこ。
倉さんが返事来たんで、
すみません、今日できなかった場合に、市川先生と出口先生、少人数でなんか打ち合わせみたいな。
それは自分でオーガナイズしてください、アレンジ。
多分僕ら3人そんな時間かかんないと思うんですよ。
でもどっちにしろ出口先生はもうお帰りにならないですか。
僕はもうちょっと今お金稼ぎにから消していいですよ。帰るんじゃないんだよ、帰るんじゃ。そこのとこポイントにちゃって。
独り言で言うんだったら別にまずいっていう人は帰ってもいいしっていうオプションを取ってもいいし、皆さんの合意だったら。一応予定としては5時っていうことになってたので過ぎてるから、そういうオプションを取ってくれてもいい。
今日にち決めるわけじゃないんですけど、市川先生来週でこの日は研究室に来る日とかはもう全くないんですか、所長。
来週月曜しか来ないけど、先生に呼ばれなければ。
まあそれは岩井さんが
一応田沼さんいないよ。
ああ、前期やるんじゃなくて、もう
いや別に
戻ってやって。
どっちかでいいんだったら田沼さんいる来週でもいいし。
それは発表者の方がどっちがいいかっていうことになりますけど、どうし
パワポと原稿を送ってパワポと原稿をファーストクラスに送って
そんなぬるいのダメだよ。自分で録画してビデオ送ってくるのよ。ああいうのだってここにシステムあるからやってくれればさ、あとネットに
ユーストやれ。
ダメだよ、やっぱ発表しなきゃダメだよ。
録画形式なら何回でも
クオリティが上がるならそれいいよ。
それで一番いいのでいっぱい突っ込まれて帰ってくる。
クオリティが上がるだったら何も問題ない。
じゃあ
まず
じゃあ
車を決めなさい。はい。
じゃあ天気やばそうなんで今日はとりあえずなしで、各自残りの学生だけで全員やるっていうのもなんかシャッとしないんで、残りの発表者の方はアポ取るかユーストするかは残りの発表者でまた後で話し合って決めるってことでいいですか。
不正でユーストリームにとったらそれについてはコメントは
後でって言うけど別にみんな帰って今やりたいならさっさと終わったらやっていいよ。俺はまあ別に大丈夫だから。
じゃあ
五十嵐君だから日にちが合わそうって言ってんだったら別にこれ残るからやっていいです。
あ、掃除は今日やんなきゃい
ゴミ捨てるぐらいはしといてちょっと。
これだけ。じゃあ今日五十嵐さんどうしたの？
これは別にお開きになってこの後やってくれるのであればこれはね。
じゃあ今日とりあえずお開きにしてもう時間やばい人は帰るっていう。
一人だけだったら。
超帰りづらい。
35分からもしやるんだったら。だってやるなら見てくよ。だってかかんねえだろ本当に。1時間か1時間半でしょ。
伸ばして1時間手がいるんだったらそれはやった方がいいんじゃない？
いやでもさ一応オフィシャルは5時までにしてあるから。なんか予定入れてあったりしたし。再スタ行きたいんだけどさ。今日ありますよ北朝鮮戦が。
それが一番気がかりだ。
まあそうか。あっちは大丈夫。
6時半から間に合うわけないん
あ、
ですよ。
俺も
サッカーの試合みたい。
お前俺チケットあんなかった本当ですか？
再スタの。
いやそれは帰っていいんじゃない
それはちょっとそれ最初に言っていただければ
いいよ別に後半だけ行くから。
それもったいない。それ
だって濡れに行くんだもん。自由席だから。
屋根がないの。
屋根がないとこですか。
そして行かないっていうオプションが出てきてるから開封したい。北朝鮮戦だし。